Is that what you're going to do? You're going to stay here and help me record my video? Hello. This is stage 9 of the programming videos. If you hear any strange scratching noises, that is my uncle's cat Grace rubbing her head up against my laptop. If you hear any strange banging noises, that is Will upstairs opening and closing cupboards. 10 imaginary points for anybody who gets the reference Will and Grace. That being said, tonight's video is a little bit different. This is not one that I would necessarily expect you to watch. This one is sort of an extra advanced video that is available if you wanted to watch it, just in case we end up using it. And the next video will be something similar. These videos... Now she's rubbing up against the screen. These videos don't necessarily... these videos are a little bit more advanced, I guess would be the best way of putting it. So it's not necessary for you to watch them unless we actually end up doing something like this for next year's robot, but they are available to you if you want to know a little bit more, and they do provide some more opportunity to see what some code might look like. That being said, what we're talking about tonight is something called command-based programming. So what we've been doing so far is iterative programming. That is that whole, you've got an init method for everything and then a periodic method for everything. And while that works for most things, sometimes a different paradigm works a little bit better if you're trying to do a lot of different things at once, or if you're trying to segregate your code into different sections so it's easier to deal with. If you noticed, as our robot code for the earlier examples, before the BP example and the PIT example, it was starting to get a little messy. There was a lot of stuff in there, and it's kind of hard to keep track of everything. Command-based is one of the things that can sort of help you by forcing you to break up your code into different smaller chunks and only focusing on the smaller chunks in order to deal with different things. Now, that being said, command-based is quite a bit harder. It's a lot more difficult to keep track of what your code is doing if you're a beginner programmer and you try to modularize it. But it is useful. There are some teams who think that command base is ridiculous and they like to do it their own way, which is fine. But for beginner to intermediate teams who aren't to the level where they can design their own robot code management structure, command base works just fine. Which is probably not the popular opinion, but whatever. That being said, tonight we're going to see the generic structure of a command-based program, as well as how to set up a drivetrain in command-based. The basic structure of a command-based program has 3 files: oi.java, robot.java, and robotmap.java. Robot map, which is what I have open now, which has nothing in it, is just a place to store constants. Normally what you'd store here is things like what actions map to what button on an Xbox controller, what PWM port you have hooked up to the motor controller that controls the front left motor, what digital I/O ports are required for the right side of the drivetrain's encoder, that sort of thing. OI.java is a little bit different. It does have some stuff in it because I do like to show just the general idea of what you would want an operator interface to look like. The OI class stands for operator interface, and it's where you define your joysticks or Xbox controllers, and all of the actions that they can perform. We'll see a little bit of this when we look at the second video. We won't see too much of it when we look at the drivetrain example. There won't be much in OI, but this is the general idea. Now, one thing I do want to talk about, what you're seeing here is something called a singleton class. Basically what that means is there can only be one instance of the class OI at any given time. You can't create multiple operator interfaces like you create multiple motor controllers or multiple speed controller groups or multiple encoders. That being said, you can just sort of copy this general structure in order to make your code work. The only place that you're going to be modifying is either inside private OI and then the parentheses and then the brackets, or well outside any of what already exists. You'd be modifying something down here, which we may get to see a little bit of when we talk about the drivetrain example. The last thing is something that you should be fairly familiar with, which is robot.java. Robot.java is very similar to what you had before when you were doing the iterative robot examples from the earlier videos, with the exception that there's a couple of spots where you really shouldn't be messing around anymore. If you remember, originally what we were doing was we were putting stuff that we wanted our robot to do in disabled periodic, autonomous periodic, and teleop periodic. These have sort of been taken away by something called the scheduler. And the scheduler is what keeps time for your command-based program. It basically makes sure that the different commands and subsystems, which we'll talk about in just a second, are all in sync with each other, I guess would be the best way to put it. Basically making sure that commands that are supposed to be running actually get run, commands that aren't supposed to be running aren't running, commands that should be cleaned up or should be end properly, that sort of thing. And it will make a lot more sense when we start to see different structures of different things in the code. But to get more to my point, with the scheduler being there, you really shouldn't be putting anything in the disabled periodic, autonomous periodic, and teleop periodic methods. The init methods are okay. And of course, robot init is still fine. Provided that you use the same rule of not putting too much in robot init, disabled init, autonomous init, and teleop init. That way you don't slow the start of any of the periodic methods. But you sort of have to gauge it with your better judgment, but for the most part, the only things that you'll be modifying in your robot.java class is this section right here. You can see that what we do is we create something called a static reference to the instance of our operator interface, our OI. Basically, all static means is that you can reference it without creating an object. It's kind of difficult to explain with the way that we went through this class. Well, not class, I should say. Class is in my head because originally I had this designed as a class, and now it's really just sort of a mishmash of robot programming videos. But without having actually gone through how to program in Java properly and just doing this whole mishmash thing, it's kind of hard to explain without going over like a few hours worth of information. So we'll see how we use the OI in a little bit. But that being said, this is just the general structure of a command-based program, and there are a couple of things that we're missing. We're missing subsystems and commands. Subsystems use commands. Commands use subsystems, and subsystems have commands. Bear with me, getting tired. Subsystems are like your drivetrain, an arm, a shooter, that sort of thing. Commands are things that do things with those subsystems. So you'd have a command for arcade drive. You'd have a command for tank drive. You'd have a command to spin up your shooter to a certain speed. You'd have a command to set your arm to a certain angle. That sort of thing. So in saying that, let's take a look at the drivetrain example. So I'm going to open it up here. Select folder. Yes, save, do what you gotta do. So there is a lot here that just opened up. We're gonna sort of start from an easier place here and start with robot map. Now, I would like to make the case that any code that you see for command-based has not been run, has not been tested. I generally don't recommend that you try to run it in regular robot code without taking a serious look at it and making sure that you know what you're doing, because there are some things here that may not be entirely obvious. But that being said, just really quickly, as you can see, we have a whole bunch of constants in our robot map that define different things about our robot. So we've got the PWM ports for our motors. We've got the digital I/O ports for our encoders. The A channel and the B channel on the left, the A channel and the B channel on the right. We have the distance per pulse for our encoders. And then we have PID settings. And then, of course, we also have the USB port that we will be plugging in our Xbox controller to. If we look at OI, it's a little bit more complicated than before. We see that we have an Xbox controller that we create using the value from robot map, K driver USB. And we also have another method down here that returns the driver controller. The reason why we have to do this is because the driver is declared as private. That means that only things inside of OI, this block right here, can see driver unless we create a method that returns it, that gives the value that you need. The next thing that I wanted was robot. Robot's already open. So robot looks a little bit different. If you look, we've got the OI and the drivetrain, and we also have this thing called command autonomous command here. And what that is for is my autonomous command, the command that I want to run for autonomous, is going to be stored in that variable. And then we're going to run it when we get to autonomous in it. But we'll see that in just a second. So if you look, we've got a drivetrain, and we just say drivetrain equals new drivetrain, and this is something that I created. And we use the values from robot map to set up its PID loop, which is internal to it, and we'll see it in a second. We also create the autonomous command variable with something called go to set point. That is a command of the drivetrain subsystem that we can use in order to go to a set point. Similar to how we saw in the encoder example, how we can go to a set point sort of generically, this code uses a PID controller to do that same sort of thing, to go to an exact distance of travel. In this case, go to set point takes in a number of inches, so we specify that same 60 inches. Now the only other thing that we see in here is autonomous command.start and autonomous command.cancel in autonomous init and teleop init respectively. Autonomous command.start just tells the subsystem that that command uses, hey, I want to run, I've got stuff to do, let me do it. Autonomous command.cancel just says, if this command is not done running yet, cancel it right now. That being said, let's look at our first example of a subsystem. So the only subsystem that our robot has is a drivetrain. Specifically, it is a PID subsystem. There are really two types of subsystems, a regular subsystem and a PID subsystem. One includes all the stuff for running a PID, one does not. That's the only difference. You do need to put extends next to whatever is here for public class and then whatever your class name is. But you do need to put extends here, and then you need to say either subsystem or PID subsystem here. And you may get warned by Java that you need different things in order to get what you want to work. Just follow along with this video and most of them should be worked out by the end. So you'll see some things similar to what we did with the other programming training videos. We've got speed controllers for our motors, speed controller groups for the left side and the right side of our drivetrain, a differential drive object, and 2 encoders. Fairly straightforward. The only thing that's a little bit different here is super.pid. Basically what we're doing is we're handing in that proportional, integral, and derivative value into the PID subsystem. We're handing those values in so it can do its thing. We don't really care how it does it. We don't have to write the code to make it do it. We only have to hand the stuff in. You then see us create all of our different motor controllers, speed controller groups, the differential drive, and the encoders. And then you see the set continuous thing, which we won't really talk about. It may not even be necessary. That was just a guess. And then, of course, set absolute tolerance. We're just setting the tolerance for whatever set point we specify for our PID controller. We have 2 other methods here. Return PID input, which is just like PID source from the PID example. We're just going to take the left and the right side encoder, get their distance, and divide them by 2. We also have use PID output, which just does the same thing as the PID output object that we created for the PID example, and that just does drivetrain.tankDrive and uses the output for both sides. We're going to skip this for just a second. We have a reset encoders method, which is called to reset the encoders. We have an arcade drive method, which takes in something called a generic HID, or a generic human interface device. And basically, all that is like a joystick, an Xbox controller, anything that you can really think of that allows you to control the robot. And basically what we do with it is arcade drive. We call it the arcade drive method because that's what it does. It gets the Y side joystick. It gets Y on the left-hand joystick, and it gets supposed to get X. Error on my part. And then it gets X on the left-hand joystick. Bear with me, I wrote all of these very, very quickly. We have a tank drive method, which takes in a speed for the left side of the drivetrain and the right side of the drivetrain and just puts them into the differential drive tank drive method. And then, of course, we also have a stop motors method, which just calls on this tank drive right here and specifies 0, 0, stop the motors. Now, the one thing that we didn't talk about is this, init default command. And basically what that means is we're specifying the default command to run on the subsystem when no other command is running. So for like an arm, you would want this to be a command that stops the arm from moving. For the drivetrain, you want this command to be whatever allows you to make the drivetrain move with whatever type of controller you're using, whether it be a joystick, an Xbox controller, or something custom that you made. In this case, we call the set default command method inside, and we specify that it needs to be a new arcade drive. The next thing we're going to look at is the 2 commands that we make use of. The first one will be arcade drive. So commands have technically 5 pieces. There's only 2 that you absolutely have to have: a constructor and the isFinished method. The constructor is this thing right here, public arcade drive. You call super, which just does some background setup that you don't have to worry about, and requires. Requires tells the scheduler that we talked about before what subsystem this command uses. In this case, we specify that it uses robot.drivetrain. If you remember, we had a variable called drivetrain in robot that we made accessible by making it public. That is what that's for. We are specifying that this command needs the drivetrain subsystem in order to work. The other thing that I said that was required is the isFinished method. This just returns a true or false value indicating whether or not this command is done running. For something like a default command, this is normally going to return false all the time. There may be some scenarios where it doesn't have to, but for the most part, especially where your drivetrain is concerned, it's going to return false. Now, the only other thing that I wanted to mention was the three other methods and the one that we see here. The other methods are initialize, execute, oh, there's actually four, end, and interrupted. I believe it's called initialize. Yes, it's initialize. Initialize is for setting up your command. It's called just after start is calling your command and just before execute. Execute is called roughly every 20 milliseconds, similar to how the periodic methods worked in iterative robot. End is called when isFinished returns true. And interrupted is called when the subsystem is told to start running another command while it's running a command already. So like, let's say you were running arcade drive and then you tell your drivetrain subsystem to run go to set point, which we'll see in a second. Before arcade drive ends, interrupted will get called. So that way you can do things like clean up and make sure motors are stopped if you need to and that sort of thing. In this case, we only call execute. Or we only create execute, I should say. And what we do is we say robot.drivetrain.arcade drive, and then we just hand in robot.oi.getDriverController. If you remember from the OI class, all that does is it gives us our driver object that is an Xbox controller so that we can control the robot. Now the last thing that we're going to talk about is the go to set point class. This one is quite a bit different, and it includes most of the parts that you saw before. Now, there is one thing that I forgot here. I'm going to put it in right now. Robot.drivetrain.disable. So, we have our constructor, which calls super and specifies requires. It also resets our PID controller and sets the set point based on what we handed in. So if you remember, our autonomous command in robot specified that we wanted to go 60 inches. The cats are fighting upstairs. Wonderful. Anyways, where was I? That's right, go to set point. So basically that 60 gets placed in this variable and we can hand it in to set point right here. The next thing that we do is we say in initialize, enable the PID controller. All this does is that same sort of thing from the PID controller example where it enables the PID controller so that it runs correctly on its own time. In the execute method, what it does is nothing. There's nothing that needs to run here. The PID controller runs in the background. It doesn't need any help, so we just let it do its own thing. The isFinished method works a little bit differently though. In this case, we're returning whether or not the PID controller is on target. So if it's not, the command will continue to run. If it is on target, the command will call its end method and finish out. Now, end does a couple of different things. It stops the motors, because once we get to that 60, we don't want the robot to coast, we don't want it to drift, we want it to stop dead. And we also call disable on the PID controller, just to make sure that it doesn't try to keep moving after the command is done. And then, of course, the interrupted method, this gets called just in case something else tries to interrupt this command. We just call end to make sure that the PID controller is stopped, and so are the motors. Fairly straightforward. Now, I want to premise this video with, I don't think premise is the right word because it has the prefix pre, but postfix. I want to postfix this video with, this is a fairly complicated way of programming a robot. The next video is going to be much worse in terms of complexity anyways, and we probably won't go over everything. But that being said, command-based is a really interesting way of programming a robot. It allows a lot of flexibility and modularity to how you set things up, and can make things like running multiple things on your robot simultaneously very, very easy and fluid to implement once you have all the basic structure set up. But I can understand if after this video you're a little confused. And when I first started to learn about command-based, when we were looking to do stuff for BP in 2013, I was very confused. That being said, if you have any questions, like all the other videos, you're more than welcome to ask. I did mention in previous videos my surgery for my gallbladder is coming up, but if you have questions, Facebook, email, text, call, whatever you can do to get a hold of me. If you leave a message, fine, I'll get back to you when I'm up to it. But I want you to ask questions if there's anything about this that really doesn't seem like it makes sense to you. More than likely, with something as complex as this, I'll ask for a little bit of time with you to sit down at a build session or on a weekend or something like that, because this is not something that I could easily explain over the phone or in a text or in a Facebook message. It's very complicated stuff. I mean, this video is already going to be longer than any video that I've made so far, so just bear that in mind. Longer than any video so far without including demonstrations anyways. So just keep that in mind when you're asking your questions, and if you want to know more, I'm more than happy to try to satiate that need. Now in the next video, which will probably be the last one for a while, we will be talking about a command-based version of BP. This is a hacked up version that I created from memory, and is a bit different from what BP originally was, simply because some of the programming paradigms have changed, and it also includes a couple of things that I've thought about over the years that could have been changed on BP to make things a little bit easier in a competition setting, and remove some clutter. That being said, there are some things that aren't included, like BP could hang from the pyramids in that game. That's not been included. That's a whole different debacle. But that being said, any questions, let me know. Otherwise, you're welcome to stop here, or if you'd like to continue with some of the more advanced stuff, you can move on to the next video.